Kia ora, Year 12s and 13s and anyone else out there watching. Here are two questions from class today from the long starter sheet. So again, both of these are out of the 2020 paper. The first one is a locus problem. And because we're just starting out on loci, I'm going to go really slowly through this one. This is an excellence question. Hopefully you'll see that if you follow the method of letting z equal x plus iy, you can work this one through just by applying some definitions pretty easily. And the second one is one where we have to solve this equation. So this is one where we're looking for finding complex roots using de Moivre's theorem. Right, so let's look at the first one. We'll start by letting z equal x plus iy, and then we're going to substitute in here. So x plus iy plus I squared is equal to x plus iy minus I. And the magnitude is squared. Whoops, it's not a minus, that's a plus. And that equals 10. So if you were physically present in class today, you would recognize from this that the next thing that I'm going to do is group the real and the imaginary parts and go from there. So we get x plus I into y plus 1 here, and x plus I times y minus 1 squared, the magnitude squared, is equal to 10. So we know that the squaring is going to make things just like one step cleaner, because I don't need to do any square roots, right? So I'm going to have a square root squared. So what I get to now is x squared plus y plus 1 squared plus x squared plus y minus 1 squared, and that equals 10. Now all we have to do is to clean this up and get it into the form desired, which is x squared plus y squared equals something. So what we're getting here is the locus that's describing a circle. X squared plus y squared plus 2y plus 1 plus x squared plus y squared minus 2y plus 1 equals 10. What goes? Well, the plus 2y and the minus 2y simplify away. We get 2x squared plus 2y squared plus 2 equals 10. And that gives me x squared plus y squared equals 4. Right, that's dividing everything by 2 and cleaning up the constants. So here's my final answer, and I don't think we were asked to describe it. No, we were just asked to find the equation of the locus. Usually if you're doing a locus problem, you should say what it is, and you should say where the center is and where the radius is. Right, so this one is a circle centered at the origin with radius of 2. Had to think about that for a minute there. I'm still thinking about that. Yeah, it's been a long day. There we go. X squared plus y squared equals 4, and the radius is 2. Right, let's look at this next one. So we have to solve this equation, and k is a real constant, and we have to give our solutions in polar form in terms of k, and that's a good thing. It's going to speed this up quite a bit. So when I first taught how to find complex cube roots, it was either in class or in a video, one of the things I said is that examiners really like to give examples where you've got a negative number, right? So z to the power of 4 is equal to this. Well, we know that this is a negative number. We're going to let z equal r cis theta. So on the left-hand side, we get r cis theta to the power of 4. And I'm just going to show you why we want to fix this up. So it's equal to negative 16k to the power of 8. So this is a number. And we could think of that with an angle of 0. Plus the spin arounds, right, which we've done. So I'm not going to go right through that again, but basically the angle could be 0, or we could think about it as 0 plus any number of revolutions. But if we do this, where we get to is r to the power of 4 cis 4 theta is equal to this. And this is a problem. R to the power of 4 is equal to this. We want r to be a real number. So the way to get around this problem is as follows. So whenever you see one where you have a negative here, we think about it as saying, well, here's my negative 16 over here. that has got an angle of, it's got a length of 16 k to the power of 8 and an angle of 180 degrees. So we write it as 16 k to the power of 8 cis pi, or 180 degrees if you're working in degrees, plus the revolutions. That means that here we've got r to the power of 4 cis 4 theta by de Moivre's theorem is equal to this. Working through this gives me r to the power of 4 is equal to 16k to the power of 8. R is equal to 2k squared. And I should probably say here by de Moivre's theorem. So let's just scribble that down so it didn't fall out of the sky. 4 theta is equal to pi plus 2n pi. Theta is equal to pi on 4 plus 2n pi on 4. Theta is equal to, okay, so actually I'm going to leave this like this unsimplified because it's going to make my brain work better when I go to link it up with this. I'm going to have 4 solutions here and they're going to be evenly spaced around the circle. So Z1 is 2k squared cis pi on 4. I'm getting that by sticking n equals 0 in there. Z2 is what I get when I have n is equal to 1. So I'm going to have pi on 4 here plus 2 pi on 4 here. So 2k squared cis 3 pi on 4. Z3, so I've got 1 here, 1 here. Now I'm going to come back here and here. So Z3 is 2k squared cis negative pi on 4. And Z4, 2k squared cis of negative 3 pi on 4. I don't think you'd get penalised if you did these as 7 pi on 4 and 5 pi on 4, but as I've said heaps, we like to end up with our values between 0 and pi and 0 and negative pi. Okay, so that's 2 more questions done. I've got 1 left to go. People in my class, if you've got questions or comments, feel free to send me an email. Thank you.